So good afternoon, everybody. This is about superposition principle of waves. So this is about the mixing of two or more waves, like at a single point if more than one wave act. The resultant wave, how it is formed. That's about the principle of superposition. So at a given point, for example, you have a wave here, just one wave here. This is one wave. To the same place, another wave comes, like the same way or same phase. Same phase means their crust and crust join, their trough and trough join. In this way, if you have two waves meeting at a single point, the resultant wave has the same phase, but the amplitudes will be increased like this. Their phases will be same. That means their crust, trough, trough will all join together, and their resultant wave will have more amplitude. Suppose if this wave its displacement is y1, this wave has a displacement y2. This will have a displacement equal to y1 plus y2. This is the idea of principle of superposition, and it says that waves generated after mixing of two or more waves will have a resultant displacement as vector sum of their parent waves. So for example, if you have two waves in the order, suppose this is one wave and this is another wave which is exactly opposite to that means exactly out of phase, then you get a resultant wave as just a line, nothing more. No amplitude will have, because this amplitude will be cancelled by this amplitude. So this is what the superposition principle says. When different waves of different amplitudes or a displacement y1, y2, etc. are superimposing, that means when they meet at a point, then the resultant waves amplitude will be y is equal to y1 plus y2 plus y3, etc. Now this principle can be used to explain waves propagating in a string. The waves propagating in a string. That means you have a stretched string and a wave is formed in that. Suppose you give a boundary for that wave. That means a string has a starting point and ending point, and those two are fixed. In that case, there's a special wave formed called a standing wave. And that standing wave is what we are going to discuss today. Standing waves produced in a stretched string. So here is a wave pattern. This is our stretched string. And these two are fixed. This is the boundary. These two are fixed here. These boundaries are fixed. Now you produce a wave here. Just this wave goes and this goes. This is propagated. This reaches here. Again it reaches here and it comes up to the boundary. Up to here it comes. Hitting the surface, this wave retraces its path. It comes back like it's get reflected. Like this it goes. Finally it reaches this point. So these kind of waves are called standing waves. They form a particular structure after getting reflected from other surface. Suppose this wave, like the first wave goes in the forward direction, let its displacement be y1, and that comes back as a displacement y2. So at the superpositioning point, total displacement y is y1 plus y2, y1 plus y2. So that is why some places you get some places with more amplitude, some places with a very lesser amplitude, again place with a greater amplitude, again with a low amplitude. These points where you have a low amplitude or resultant amplitude as a 0, we call as nodes. And the other places where we have more amplitude, this is a place with more greater amplitude, a place with greater amplitude, we call them as antinodes. Now we told these two are two waves and they have different displacements y1 and y2. Resultant is the sum of their vector sum of their displacements. So this y1, this displacement, for the first wave we can represent it as a sine of omega t minus kx. This was the representation given in terms of lambda or in terms of time period. Anyway we can represent it as a sine omega t minus kx. Hope you remember what is k. And one more thing, the second wave y2, which is returning back, which we can represent as minus a sine omega t plus kx. This plus shows it is in the opposite direction of the first wave, and this minus a shows its amplitude is opposite. That is, suppose if this wave starts in the upward direction, the next wave is in the downward direction. To represent that, we give a negative sign also. So considering these two, when the waves get added up, the resultant we can write as a sine omega t minus kx plus minus a sine omega t plus kx. This is a negative kx, this is positive kx. The resultant displacement is y is equal to a sine omega t minus kx minus a sine omega t plus kx. So I have explained why this negative comes and why here it is positive. So this negative sign, let's take outside. This a minus a, let's take outside. Then minus a, if you take outside, here is this term will come first. That is omega t plus kx, sine of omega t plus kx minus of this term, minus of sine omega t minus kx. So this is in the format that sine of a minus, this is sine a minus sine b format in mathematics, sine a minus sine b format. And that sine a minus sine b is equal to 2 cos a plus b by 2 sine a minus b by 2. So here we have used the formula. This equation what you are using is sine a minus sine b is equal to 2 cos a plus b by 2 into sine a minus b by 2, a minus b by 2. So this is the formula we are using here. As per that, we have this full term is a, that is a is omega t plus kx and b is omega t minus kx. So here the result of this will be minus 2, minus a is here and this 2 is coming here. Cos of a plus b by 2, a plus b by 2 will come omega t plus kx plus omega t minus kx by 2. This kx cancel, then you get it as 2 omega t by 2, that is omega t. That's why you can see minus 2a cos omega t here. And next is a minus b, sine of a minus b by 2. So this is sine a minus b by 2. This a minus b by 2 will come omega t plus kx minus of omega t minus kx by 2. This is equal to omega t minus omega t will be there, kx, this will cancel, kx minus kx, that is plus kx by 2. So you get 2 kx by 2, that is kx. So that's what written here. So two things, one is a plus b by 2, that is omega t. A minus b by 2, a minus b by 2 is omega t plus kx minus of omega t minus kx by 2, which will give you kx. So you get the result as minus a 2 cos omega t sin kx. So y is minus 2a. This term we write first, sin kx into cos omega t. Here this is the time independent term, that is there is no time in this, only kx is here. This term is actually our amplitude of the wave. This is the phase term. So the resultant amplitude of this wave, standing wave, is 2a sine kx. 2a sine kx. So the resultant amplitude depends on the values of k, x and a.